convert decimal number to binary number. In today's class, we'll see how to convert decimal number to octal number. Octal number, it means that I'll have some decimal number, I need to convert it to octal number. So let me take as an example 985.26 base 10, that I need to convert it to base 8. So here I put the question mark. So you need to find out what is that question mark. So here if you observe, I have the integer part and as well as the fractional part. So integer part and fractional part should be separated whenever you are converting it from decimal to any other number system. So in the previous case, decimal to binary you were converting. So whenever you were converting decimal to binary, binary means base 2. So you were dividing it with 2. But here you are converting it from decimal to octal. So you need to divide it with 8. Okay, so now and you also have the fractional part. So fractional part should be multiplied with 8. That is how you need to do. So here when you divide it, in the sense 8 ones are 8. So 1 is the remainder here. So 18. 18 in the sense 8 2s are 16. So 2 will be the remainder 25. So 8 3s are 24. So 24 in the sense 1 will be the remainder. Next 8. 8 1s are 8. So 4 will be the remainder 43. 8 5s are 40. So 3 is the remainder. Next 8 1s are 8. So 7 will be the remainder. 8 0. So 1 is the remainder. So either you can terminate when you get a remainder as 0, or you can terminate when your here this value is lesser than this 8. Okay, so and since this is the integer part, you have to write it from bottom to top, and since this is the fraction part, again you need to multiply it with 8. 0.26 into 8, you need to multiply it. So 0.26 into 8, 8 6 are 48. So 4, 8 2 is 16, 16 plus 4, 20. So 208, so 0.208, 208. So here what you need to do, you need to separate the fractional part and the integer part. Integer part you write here and fractional part you need to take here. So 0.08 into 8, it will be nothing but 0.64. Here the integer part is 0. So again 0.64 into 8. Okay, 4 8s are 32. 8 6 are 48, 48, 49, 50, 51. So 5.12. Okay, so 5 is a remainder. So again you can proceed. Integer part I have represented here and fractional part I'll take here 0.12 into 8. So 8 2s are 16, 8 1s are 8, 9, 0, 0.96. So integer part is 0. Again if you want, you can just proceed one more time. So 8 6 are 48. So 8 9s are 72. 72 plus 4, 76. 76. So after 2 decimal points, I need to put a point. So integer part I have to write here, and since my fractional part value is not 0, I can just proceed it, or I can terminate after 4 5 values. So here I've got 4 5 values, so I'll just terminate here. And since this is a fractional part, I need to write from top to bottom. Okay, so the overall answer for the conversion 985.26 base 10 is nothing but this. I need to write from bottom to top, so which is nothing but 01731 point, and this is for the fractional part which I need to write from top to bottom, so it is 20507 base 8. Okay, so this is a conversion from binary to octal. Sorry, not from binary, it is from decimal to octal, decimal number to octal number. Okay, decimal to octal conversion. So we'll see one more example. 128 base 10 converted to base 8. So 128, since I have only the integer part, I have to take only the integer part and divided it with 8. So 8 1s are 8. So 4 will be left out, 48. So 8 6 are 48. So 0 is the remainder here. So next 8 2s are 16. So 0 is the remainder. Next 8 zeros are 0. So 2 is the remainder. So here for this 128 base 10, I need to convert it to base 8. So, and if you just observe, it is just the integer part. So you need to take from bottom to top. So it is 0 to 0 0. You can write this 0 or you can leave it off. Both are same only. Okay, so this is a conversion from decimal to octal. Now in the third case, we will try to convert decimal to hexadecimal. Decimal to hexadecimal in the sense base 10 to base 16. So let me take one small example. 156.23 base 10. This I need to convert it to base 16. So here if you observe, I have both the integer part as well as the fractional part. So first I'll take the integer part 156. I need to divide it with decimal to hexadecimal. So you need to divide it with 16, and fractional part you need to multiply it with 16. Okay. So here if you observe this 2 I cannot take, total 156 I need to take. So 16 nines are 144. 144 in the sense 16 nines are 144. So 12 will be the remainder. Again 16 0 0, so 9 will be the remainder. But in the hexadecimal you will not have 12. So instead of 12 can be, A is nothing but 10, B is nothing but 11, C is nothing but 12. So instead of 12 I need to write as C. Okay, so this is for the integer part, and you need to write from bottom to top. Bottom to top. Now here when it comes to the fractional part, you need to multiply this fractional part with 16, in the sense 0.23 into 16. When you multiply 0.32 into 0.23 into 16, you will have as 3.68. So 3.68, 3 integer part I need to write here, and fractional part I need to take here. So 0.68 into 16 I need to do. So when you do 0.68 into 16, it is nothing but 10.88. Okay, so .88. So 10.88, integer part is 10 and the fractional part is 0.88. So here again what you need to do, you need to multiply 0.88 with 16. So 0.88 with 16, when you multiply 0.88 with 16, you will get as 14.08. So again you will have 14 here, and the fractional part 0.08 into 16. So multiply 0.08 with 16. When you multiply 0.08 with 16, you will have as 1.28. So since I'm not getting the fractional part as 0, I can just terminate here. But here if you observe, here I've got a 10 and here I've got a 14. So 10 and 14 will not be there in hexadecimal. Instead of 10, you have A, and instead of 14, you have E. So now I need to write this from top to bottom, and this from for the integer bottom to top. So the overall value will be equal to the integer part 156. It is nothing but 909C point, and this I need to write from top to bottom. So 3 I'll write as it is. 10 I'll not have, so instead of 10 I need to write A, and instead of 14 I need to write E, and instead of 1 I can write 1 only, because hexadecimal number consists of all the values from 0 to 9 and A, B, C, D, E, F. So this is the conversion from given decimal number to hexadecimal number. Okay, so we'll see one more example related to this. 250 base 16, sorry, base 10, that you need to convert it to base 16. So since I have only the integer part, I have to divide it with 16. So 16. So 16 ones are 16. 16 ones are 16, in the sense 9 will be left out, 90. So 16 5s are 80. So I'll be left out with 10. I'll write that 10 here. and 16 zeros are 16, and I'll have 15 left out, so I'll write 15 here. As I've already mentioned, 10 and 15 will not be there in the hexadecimal, so 10 I need to represent it with A, and 15 I need to represent it with F, and this is for the integer part. Anyway, I don't have fractional part, so I need to write it from bottom to top. So it is nothing but FA base 16. So 250 base 10 is nothing but FA base 16. This is how we convert the given decimal number to hexadecimal number. And as an example, we'll take one more 0.72. Here I have just taken only the fractional part. Now I need to convert it to hexadecimal number. So since I have only the fractional part, what I need to do? I need to multiply this fractional part with 16. 0.72 into 16. Okay, so I'll get as 11.52. Okay, so 11 is the integer part and 0.52 is the fractional part. So again, I need to multiply 0.52 with 16. So I'll get as 8.32. So 8 I'll write here, and again the fractional part 0.32 I'll write here. So again I need to multiply 0.32 with 16. So when you multiply 0.32 with 16, you'll have as 5.12. So 5 is a remainder, and 5 is the integer and 0.12 is the fractional part. So 0.12 into 16. I need to again multiply 0.12 with 16. So I'll have as 1.92. So again I have the integer part, and this will proceed. Okay, but I can just stop after 4 or 5 decimal points. And here if you observe, I have 11. 11 won't be there in hexadecimal. Instead of 11, we'll represent that with B. 851 it will be there. And for the fractional part, you need to write from top to bottom. So the final answer is 0.B851 base 16. This is for 0.72 base 10, which is nothing but the decimal to hexadecimal conversion. Okay, so we'll just have the summary now. See, we have seen how to convert decimal number to binary, decimal number to octal, and decimal number to hexadecimal. So whenever you are converting the decimal number system to any other number system with base n, then this decimal number will have the integer part and the fractional part. This decimal number will have integer part and the fractional part. So what you need to do, integer part you need to divide with the base n of the other number system, and the fractional part you need to multiply with base n. Okay, so this is how you need to proceed with the conversion. Thank you.